Before I get started on the webinar content, I just really briefly wanted to introduce Tejas Networks, since many of you may not know who we are. We're basically the leading telecom equipment provider in India. We're the biggest. We're headquarters in Bangalore. We also have offices in over 75 countries. Our headquarters in the Americas are in Dallas, Texas, and Mexico City. We have over 500,000 network elements deployed globally and over 12,000 network elements deployed in the Americas. We've been here for quite a while. Some of you may not recognize us because we've done a lot of our selling through partners that use their own brand. So it's very likely that you have seen our products before, or even trialed or utilized our products before, and you don't even realize it. So really quickly, we have a broad range of services and technologies. Today, I'm going to be focused on our ultra-converged broadband product, which is designed for rural networks, hence the title of the webinar. All of our products are basically managed under a single manager to give a similar look and feel for doing things like provisioning services and troubleshooting, whether it be an Ethernet service or a PON service or a WDM service. We, in our portfolio, have everything from layer 0 to layer 3. So basically, the manager manages at all layers and does some correlation between the layers. We have a technology called software-defined hardware, which I'll reference a little bit today as I go through the generic presentation. And what it allows us to do are a couple of things. It lets us reduce the cost of the hardware, number one, by essentially building our own components or combining the functionality of multiple components into a single component that we would otherwise have to buy multiple components for off the shelf. And it also allows us to extend the longevity of the devices. So we can literally add new functionality to the devices that would normally require a hardware upgrade, like a new protocol or something like that. We can do it through firmware, essentially, just using these programmable chips. We design all of the products to be future ready, and what we mean by that is we design the chassis for the thermals to accept what we know will be next generation cards and next generation fabrics. In fact, the ultra-converged broadband technology that I'm going to talk to you about today started with GPON. Now we're upgrading it to XGS-PON and NG-PON 2. And it started with fabrics as small as 64 gig and now has fabrics as big as a terabit, all in the same chassis family. So we try to extend the life of the products that you buy. All right, so digging into the webinar. So what are we going to talk about? Introduction of the digital divide problem. So I want to talk a little bit about digital divide. Most of you are familiar with what's going on rural versus urban, but I want to talk a little bit about what dynamics are changing due to COVID, which will lead into some of the best practices and tools that I talk about for deploying in rural environments. And I'll talk a little bit about rural deployment challenges that we've come across and some of the tools we use to solve them. Then I'll talk about technologies and operational models for cost-effective rollout. So it's not only the technology you buy, but it's also the way you design your network. There's certain things you can do from an architectural standpoint that will make your rural rollouts much more cost-effective. And then I'll talk a little bit about the Tejas value proposition and some success stories and key takeaways. All right. So really quick, the age of digital living, studying and working from home. So this is what COVID has brought us. Now, all of this was already starting long before COVID, but COVID has really accelerated things. And a lot of the things I'll talk about now, you know, are already going on, but I want to talk about them as they relate to urban or rural broadband, just because it does amplify the effects of what was already going on in rural environments. So as you know, people are moving to work from home and study from home. So basically what that means is, now if you think about how most people work and live in rural environments, they often maybe live out in somewhere that's very rural, and then they actually work somewhere typically that's less rural or even urban, right? So typically all the high bandwidth capacity that they were consuming, they were really conserving in an urban area, not in a rural area. And for years, we've been trying to catch up in the rural areas in terms of the amount of bandwidth that we've been rolling out, but the bar wasn't that high because basically people were just looking at entertainment, and maybe browsing the internet, doing some emails and things like that at night. But with work from home and study from home, you're talking about really intensive video utilization, right? So, study from home is essentially an all-day conference call. And work from home, you have conference calls on and off, and you're constantly talking to people. So over-the-top entertainment, now you might say, well, we had that before in rural areas. Why does that matter now? One of the reasons is that now that we've shut down all outside types of entertainment, people are looking to entertain themselves in their homes. And so we are actually seeing more traffic flowing from over-the-top services, things like YouTube and Netflix, as a result of COVID going on. And we think once people get used to that, it will continue to be that way. And in fact, some of these trends like study from home and work from home, I think people will start to do that more in the future. And basically you'll see the requirement for rural broadband data rates actually continue to climb. And in fact, all the studies that I've seen, the market studies I've seen so far, seem to indicate that. The other thing we've added is healthcare. So doing electronic healthcare. And basically what that is doing video conference calls with people that are with doctors before you have to go into the office, so they can screen you and see if you actually need to come in and keep from having to expose you to COVID. Of course, in a doctor's office, you're more likely to be exposed. And that, again, is lots of conference calls. Automation of manufacturing and things that we used to do in the work. Manufacturing plants are getting more and more automated. That started before COVID, but now that's accelerating, which means more IoT devices for monitoring things, more maybe virtual reality, augmented reality for doing things remotely that you would have had to go into the office for. And finally, digital economy, buying things online. Right. So now everybody will say, well, I used to do that before. So why is that any different under COVID? And the reason for that is people don't want to go to stores now. Right. So now they're doing a lot more of that at home. And I don't know about you, but when I shop online now, since I used to go to stores for things I wanted to see before I bought them. But now I don't want to go to the store as much, so I will actually look for videos of those devices and video reviews. And so actually buying a single thing, I end up streaming lots and lots of video. So the dynamics in the rural environment are changing. So now what we're seeing is a ramp for the amount of bandwidth that you need to deploy. In fact, particularly an upstream bandwidth, right? It used to be we were more concerned about downstream bandwidth, and that affects some of the technologies that I'll talk about in a few minutes. But especially in upstream bandwidth, right? You're now seeing a lot more upstream bandwidth because you're doing video conferencing and you're not just streaming Netflix, right? So what are the typical deployment challenges in rural areas? These, of course, haven't changed, but just want to go through them so as we talk about some of the technologies and things, we understand why we have them. Number one is uncertainty of power. And of course, that will vary depending on where you are, what country you're in. And even what region within a country. But most places probably have access to power, but the reliability of the power is different. So that drives the need maybe for backup power systems. And I'll talk about a deployment in here that we did where we actually had solar battery backup. So some interesting things that we've done in rolling out the rural environments. Of course, your terrain is different. Sometimes you're in the mountains. Usually cities and urban areas are pretty flat. You start getting, when you get in the country, into mountains, even deserts and things like that, population density is very small. And what that means is the number of devices that you have to deploy to get to the same amount of people is more. Because in an urban area, right, you deploy a single device, you get to lots and lots of people from that central office or wherever you deployed it. In a rural area, wherever you deploy that device, you can only get so many people because they're so spread out, and you've got to deploy more of those devices, which comes into play in economics of deploying, and some things that you can think about while you're doing rural deployments to help with that. High incidence of fiber cuts. As you get out into rural areas, fibers sometimes go up on spans, up on power lines. Even if they're buried, they're less obviously buried. First of all, they're buried in dirt instead of concrete. So people tend to dig where they are, and they're generally not as well marked. So basically what that means is that people don't know where they are, and they start digging, and they cut your fiber. So what that means is you need more hierarchical protection, and we'll talk about that a little bit today. extreme climate and weather. Clearly, as you get out into rural areas, you can get into extremely cold areas in mountains or even desert areas that are extremely hot. And what that means is hardened equipment and enclosures. Sometimes we see skills gaps in the rural areas that we go into, depending on the country. It varies a lot. But even even in the Americas, we've seen skill gaps between urban and rural environments. And what that generally means to us and our customers is sometimes they need more help doing things, right? So we even have service agreements where we'll go in and do software upgrades for customers and do all the things that maybe some customers in urban areas that are staffed with more IT kind of people will do themselves. So, and luckily, companies like ourselves take care of all that stuff for you. Limited capital availability. Now, we all know there's government money funding and flowing in rural areas, and all of you, I'm sure, are taking advantage of some of that, but that comes and it goes. And one of the studies I was looking at said, though, that per equipment that you buy in a rural area, you can make roughly 1/10 the amount of money that you can make in an urban area. Now, that study may be a little exaggerated, but the gist is you're generally buying more equipment and spending more in rural areas than you are in urban areas to get the same number of dollars back, which means you don't have as much to reinvest in new things, and so you tend not to pre-build your network and stick a lot of equipment out there before you actually need it. So scalability is a nice thing. An interesting report just to show that we're actually doing good by deploying in rural areas. This was by the World Bank that put this out. And basically what they said is for every 10% rise in broadband capability that you have in a rural area, you actually increase the GDP of that country by 1.21%. And if it was a lower income country to begin with, then you increase it even more, because one of the biggest problems is in those countries is accessibility. So by deploying, getting into this business, we're doing a lot of good. All right, so technologies that you need to address rural deployment challenges. Multi-technology platforms. So this comes into the point that I made a little earlier, where generally you need a lot more locations to address the same size population because the population is spread out, which means that you have to put devices in more locations generally to get revenue. So to reduce the cost of doing that, if you have a lot of boxes, one for each application that you deploy, like Ethernet and like PON, and you deploy different boxes, then that actually costs more. And I'll talk about that a little bit. Then deploying a single box that does all of those things, you can actually save significantly by doing that, especially when you're deploying in rural areas where you have lots of locations and you're having to replicate that in many remote locations. Customized CPE solutions. So we've done some customizations of some of our CPE, and I'll talk about some of that. But we also have some hardened options and things like that we need to have in rural areas, and not only CPE but the OLTs themselves. Flexible software-defined hardware. This is the technology I talked about before, and what this is about is just prolonging the life of your equipment in the field. So, for instance, we're rolling out some XGS-PON cards this fall. They won't have NG-PON 2 day one, but with our software-defined hardware, we'll actually be able to upgrade them in the field, and you won't have to do a truck roll, which can be extremely painful in rural areas because of the distances and costly. Cost-effective single fiber DWDM. So this is one thing that maybe some of you haven't looked into. So we've been running into an increasing number of customers that are doing their own backhaul. They're not using wholesale services. They're actually building their own fiber optic rings and maybe doing DWDM over that. And what we're finding now is some of them actually have access to buying a single fiber instead of a fiber pair. Now for PON, we've transmitted on and received on a single fiber for many years, but on WDM, most systems actually transmit and receive on 2 fibers, so you need a fiber pair. And I'll talk a little bit about single fiber WDM, but it can literally say it can save you lots of money. And the trade-off is really good. You'll get a little less capacity, but you don't need the capacity in rural areas because you're not aggregating as much traffic. So it's great trade-off, good way to save some money. Multi-level protection. I'll talk a little bit about protection today, just because of the time, though I won't get into that a lot, but I have a webinar tomorrow that talks about Ethernet services, Ethernet service delivery. Well, I'll talk about some multi-level protection schemes that are useful, and I'll talk a little bit in here about some as well. And then seamless transition to higher rates. So not only to different types of PON, but higher rates of Ethernet. The reason I mentioned PON here is because Ethernet is easy, right? Even if you run him a 10100 today, or if you're giving him 10 megabits or 100 megabits, you probably ran him a 10-100, 1000, and you've got an easy way basically to expand that bandwidth. And chances are you've oversized your switch a little bit, so no big deal. On PON, a little more of an issue, right? Because you have a really restricted amount of bandwidth that you can send downstream and upstream. And on GPON, it's not a lot, right? So, and now with the demands of COVID demanding more upstream bandwidth, that's becoming an issue. So we're seeing a lot of demand where people now are looking more aggressively at technologies like XGS-PON to increase their upstream bandwidth and increase their bandwidth per user. All right, so given that, let's talk about some of the some tools that might be useful. I'll drill down on some of those that I just talked about on the previous slide. So number one, I talked about consolidation of devices to do many different things. So most of the rural providers that we talk to are doing active Ethernet, they're doing some sort of PON, and they have some legacy services that they need to collect. Now, strangely, which a lot of them actually look for different devices for doing these things. And in fact, most of the RPs that we get are RPs for that particular application, which is interesting to me because there are devices out there that do multiple. Ours is one of those, and there's certainly a lot of savings to be had. So there's the obvious savings, just the metal and the power. I can power a bigger chassis with more fabric and more capability more efficiently than I can power a bunch of little chassis, right? Because I'm taking into account all of the stuff that's in the chassis instead of just doing little bits of equipment at a time. And same thing for cooling. Where the big savings comes in though is fabric. So basically a fabric does not scale in price linearly. So if you buy 3 devices, say one for each of these, and each one has a fabric of 2 gig, so that's 6 gig in total, or you buy a single 6 gig fabric with a single device and do all of these, the 6 gig fabric will be on the order of a third cheaper. So there is a value to buying volume. So you might as well use your own volume to increase your buying capability when you buy these products. And then the other thing people don't think about is the backhaul. So you can cost yourself a lot backhaul if you're backhauling separate devices. So first of all, if you have 3 separate devices, whether you're doing wholesale backhaul or WDM, if you backhaul each one separately, you're going to use 3 waves or 3 wholesale pipes, right? So a lot of bandwidth. Now you might say, okay, I'll interconnect those switches and I'll aggregate everything up efficiently. Then I'll spit it out to the backhaul as a single pipe, which you can do. If your fabric in any one of those devices is big enough, right? So you get to the problem where your fabric's too small, basically, to do that. And plus, there's a price to interconnecting those devices. You're eating up some of the fabric, and you're eating up ports that you could be using to serve customers. So actually putting these things in separate devices is actually a very expensive proposition for you. All right. So we actually have a single device that does this stuff. I'll go over it toward the end. Just wanted to point out that we've won multiple awards over the last couple of years for the level of integration that we have. Even in some countries on the same device, we do LTE, fixed wireless as well. Not in the Americas today, but outside the Americas, in the same device we have that, and hopefully one day we'll bring it here. Customization for rural deployment. So I mentioned that you've got some weird environmental conditions and power issues and things like that. So we actually sometimes, especially for larger deployments, do some customization, some level of customization. And that will involve things like building custom enclosures. So for instance, one of the rollouts, I'll talk about it a little more, we had to build them a special enclosure because they wanted a battery backup and solar capability in the same enclosure, as well as a switch to take this was a PON deployment, to take the PON and then connect it to the switch and distribute that PON capacity then to multiple different businesses or homes. So we ended up building them a special enclosure for all of that. And it had a solar panel that sat on top, and the solar panel charged the backup battery, and the backup battery was enough for 4 hours. So if they lost their primary power source, they had 4 hours to get it back. And also we actually did a special ONT for that one, where we had a 4G SIM in the ONT, and if they dropped their PON connection, we could actually back it up with just an Ethernet connection as well. So I'll talk a little bit more about that deployment later in the presentation. One of the cool things about that was that we could actually stick that whole enclosure in somebody's backpack. So obviously some cabling had to be done at the installation site, but once that was done, we could just basically stick one of those enclosures in a backpack to that deployment, which we actually did in this particular deployment. Remote management through software, most everybody offers that. As I mentioned before, we have a single manager for all our devices. So even if you chose to buy multiple devices from us, instead of one, it would all be managed by the same manager, similar look and feel. Everything can be done remotely, configuration backup, software, all the stuff you expect to see from a manager. So I'm not going to spend time on that. The only thing I'm going to mention is that a whole field programmability with software-defined hardware, that's also can be done from the management station. It can be done remotely. So when we provide an upgrade to a card, for instance, to add NG-PON 2 to that XGS-PON card, that upgrade can actually be done from a centralized site. Single fiber. So I mentioned that a few minutes ago. I just wanted to go over what that is in case some of you aren't WDM people, since the focus on this presentation is broadband. And by the way, on Thursday, we actually have a WDM services webinar that Alan will be doing. So if you want to learn more about technologies like this to improve your backhaul capabilities, please join us in that webinar as well. But for WDM, as many of you know, generally you have to transmit and receive on different fibers. So the least you can buy is a fiber pair when you put in WDM, and your transceivers typically broadcast and receive on the same wavelength, and each of the transmit wavelength goes on one fiber and the receive wavelength goes on the other, so they don't bump into each other. And what single fiber lets you do is it lets you transmit and receive on the same fiber, and then you need transceivers that can transmit on one wavelength and receive on the other, so that you can actually put them on the same fiber. Today, this is doable with most 10 gig transceivers. Most actually provide the ability to transmit and receive on separate wavelengths. So the hardware is already out there, but somebody's got to test and build the whole filter infrastructure basically to do single fiber transmission. So there are special filter configurations and things like that that we support to support this single fiber. So not everybody can do it. They have to actually explicitly support it. And at 100 gig, for reasons I don't have time to go into here, most 100 gig transceivers were built only to support the same wavelength on transmit and receive. So a lot of 100 gig transceivers won't do single fiber transmission, period. But we're able to do it with our equipment, and that's part of the software programmability of the equipment. Using our own chip technology, we've been able to make that happen. And if any of you are interested, the page you used to sign up for this webinar actually had a sign up for one-on-one meetings as well. You can sign up for a one-on-one meeting for whatever you want, and if you want more detail on that kind of thing, we can talk about it in general. And again, it's not a capability that only we offer, but we do offer it, and we're one of the few that does it at 100 gig. So these technologies you might be interested in learning about, even whether or not you're using our equipment to do it. All right. So another interesting thing that we've run into in rural environments is the need for alien wave. So that's the ability, if you're doing WDM backhaul and you've already got a system in the ground, that's ability for us to take our Ethernet backhaul and run it over your existing WDM system without having to put in our own line system. So, and the reason this is more prolific in rural environments is because most rural environments aren't as dense. So when they put in a WDM system, they're able to use it for a lot longer. They don't ever fill it up, right? So they've got tons of extra wavelengths. And unfortunately, what most of them think is that, okay, if I want to run my backhaul from a switch or from a transponder that I plug into that WDM, I have to buy it from the vendor that provided me with that transport system. Well, that's not necessarily true, actually. So most of us can do alien wave over existing systems. Now, in our case, it's a specialty. So we've actually done it a lot in the field over many different vendors. And again, that's another thing that you can talk to us about in the virtual booth or in a one-on-one session if you want us to go into detail as to whom we've done it with and what types of technologies. But the other thing it allows you to do is it allows you to take, even if the vendor that you're using for WDM has the transponder or switch you need, it allows you to bring in competition. And because all of us rev our equipment at different times, so at different points in time, some of us have the competitive advantage. Whoever spun their equipment last generally has that advantage. So bringing in competitors basically puts pricing pressure on your existing vendor. All right. So resilience, I talked about that a little bit. There's tons of different resilience things I could talk about on the Ethernet side for running Ethernet services. I'll talk about those in the webinar tomorrow if you care to join. But here I did want to mention, since we're focused on broadband, what we're starting to see in the PON world, because most of you, when you deploy PON, deployed an OLT, deployed a fiber, and then split it out to many different homes. And the problem with that is this fiber that aggregates into the OLT, it serves up to 128 homes. So it serves a lot of homes, which are now businesses and education sites, right? So they want a little more. So you want a little more protection, basically. You want to be able to offer them a more premium service. And so there's something called Type B protection for PON systems. It's standardized. We happen to support it. That allows you to take a second fiber. It basically splits the signal coming back from the customers and lets you run it either to another PON port on the same OLT, and then you could run the fiber diversely, or to a separate OLT. And so you essentially can get equipment protection and geographical protection. I mentioned bandwidth upgrades. So the ability to upgrade bandwidth in your network. As I mentioned before, upgrading Ethernet is pretty easy, right? Generally, you've run something out there that has more capacity than they actually need today. And with carrier Ethernet, you can slowly expand that capacity without even taking down the service, which is part of what I talk about tomorrow in the webinar. But today I want to talk a little bit about PON, because PON's a little more difficult, right? PON, you have a fixed bandwidth, 2.5 gig down, 1.25 gig up, and you're splitting that anywhere up to 128 ways. Now, of course, one thing you can do to increase the bandwidth is just reduce the number of splits. So that's what a lot of people are doing. And then put in a second GPON system. But what a lot of our customers are asking us to do is provide an upgrade to XGS-PON. So what we're introducing in the fall here is cards that go into that same OLT that provide XGS-PON and GPON today. And then they will provide NG-PON 2 in the future. And the nice thing about these technologies is you don't have to rip out the GPON. So if you take that card, you put in GPON today, and then you decide you want to use a second port, you want to offer some of those same customers XGS-PON, but not all of them. You leave the GPON in place, you can run the XGS-PON over the same fiber, the same splitter, and then all those customers will have access to XGS-PON, which is 10 gig down, 10 gig up, and split however many ways you do. And so you can slowly upgrade them by upgrading their ONTs. So it gives you a nice smooth migration path to much higher bandwidth. And then the next step is NG-PON 2. And that same card that we're introducing, while it won't have NG-PON 2 day one, it will be firmware upgradable. So we'll provide through our software-defined hardware a way to upgrade that automatically to that technology, to NG-PON 2. All right. So some operational models, best practices, a lot of these you've seen or done, so I'm going to go through these pretty quickly. So, of course, all of you are taking advantage of government funding, so no need to talk about that. It's being offered pretty ubiquitously everywhere, and I think we'll see that do nothing but increase. We have seen in some areas where they're actually cutting partnerships with over-the-top providers, guys like Google or hotspot providers, where the customer did, because of name recognition, they think that a Google maybe can get more take on Wi-Fi and things like that. So the service provider actually provides the connection through PON or through Ethernet, whatever it is, and then the hotspot provider, or the Googles, the Facebook, whomever it might be, will basically provide the endpoint and then provide services over that connection, and also pay the service provider for those services some portion of that money. So good way to make some money. We see a lot of reuse of utility assets and real estate, like poles and things like that, maybe railways. We see a lot more of this, admittedly, in countries where those things are public. So a lot of service providers will ride along railways and or on poles in order to avoid having to buy their own rights of ways. And in places where those things are private, they will generally cut relationships and buy those services from those providers. So some providers, like some utilities, will give you access to their poles, and some utilities will actually sell you a wholesale service over those poles. Wholesaling, all of you take advantage of that, so I'm not going to talk about it. You can backhaul with your own network, or you can wholesale across somebody else's. Now, one thing I wanted to mention was greenfield greenfield deployments and sharing of bandwidth. So we hear a lot of talk about that, but don't see a lot of people doing it. So, and I know it's a difficult thing, and chances are if you did it, you got to do it with somebody you're competing with, right? So not always a great thing, but can save you a lot of money. So I'm curious if any of you come into the booth, it'd be interesting to talk about if you've ever thought about doing that. In the 5G world, we're hearing a lot of people talking about a common RAN and things like that. So maybe you're offering services in an area where you sell, where your backhaul network is common, but you're not your services network, right? So maybe you just build a common backhaul network and share some of those expenses. But again, haven't seen it done practically, really at all. So I want to talk about this rollout, even though it was in India, because it was a huge rollout. I just want to show some of the scales of some of this stuff. And this is where we use that special enclosure that I showed you, and that backpack where we can put that closure in a backpack, and we use that special ONT. So we developed a lot of those things for this particular rollout. And in India, we basically rolled out PON we have a contract to roll out PON to 250,000 villages or small towns, basically. And we've rolled out 75,000 of those so far, and we were able to do that with those technologies that I showed you in less than a year. So we had many, many crews, of course, working simultaneously, but because of the ease of installation and the way we packaged it, the way it could be transported, we literally had people all over the place deploying that stuff, and really deployed a lot of connections in a very short period of time. Well, we deployed 100 megabits to begin with, but as you saw in that previous one, we put an extra splitter in there so they could provide more bandwidth to any of the towns if they wanted to. And all of those towns were using them for mission critical services, things like government services, healthcare, education. And we did this before COVID rolled around, and so it was right in the nick of time. We finished up just before COVID, at least the first phase, the first 75,000. And then we've got a bunch of others that we're going to roll out. And for doing this, we actually got an award from the Indian government for one of the best equipment supplier partners that they have. So hopefully we can be yours too. So what are we actually seeing in most rural rollouts? Most of them aren't that extensive. Most of them are smaller populations, smaller service providers. A lot of the ones we do aren't government, although we do many government ones as well. So we're starting to see a lot of GPON, as I mentioned. We're seeing a lot of that to go to XGS-PON. I've already talked about that, so I'm not going to talk about it much. I did want to mention, though, that since I've spent a lot of time on PON, is that rural broadband isn't just about PON, right? So it's about Ethernet services. So we see a lot of Q&Q and VLAN, carrier Ethernet services that we roll out. We see a lot of MPLS-TP based, and there are a number of reasons they're using MPLS-TP, but I go into that in tomorrow's webinar, where I talk about Ethernet services. We don't have the time to go into that today. And surprisingly, we see a lot of legacy services in these rural rollouts, which really surprised me when I started working in the rural environment. I came from basically larger companies that targeted urban environments, but just tons of legacy stuff still out there. And that's why we chose that service offering to roll into our single product. And by the way, our product also will let you backhaul over a wholesale network or over your own WDM network, or using your own gray optics, basically, in the backhaul. So we give you many, many different deployment opportunities. All right. So that's it for best practices. I wanted to take a few minutes before we got to questions and talk just about our product. I'll try to make this very quick. I've mentioned a lot of things about the product, like the software-defined hardware, single manager, so not going to talk about that again. But I did, as I mentioned before, we have a single product, but it's actually a series of chassis. So you can cost optimize around your particular deployment. We have chassis and pizza boxes in the family. It's a single family, and in the chassis, you can put carrier Ethernet, PON. We have WDM interfaces, so you can backhaul over WDM. And of course, we don't distinguish between unis and NNIs. So you can take any number of the interfaces. They're all pluggable, so you don't really pay for them until you put in the plugs. That's where most of the cost is. So it's very scalable. And you can take any of those interfaces and you can face them toward your backhaul or toward your customers. So you figure out how much bandwidth you want to send to the customers and how much you want to put in the backhaul. All of these chassis offer redundancy on everything, on fabric, on power, on controller, on fans. So everything is redundant, or you can choose to deploy them non-redundantly if you want. And you can put any mix and match of PON or Ethernet services, or and any of the ports that take 10 gig and above basically will take a WDM optic as well. Now, many of you don't need all of those services in every location. So you may use the big chassis in locations where you need multiple services, but maybe cost optimize with some pizza boxes that we have that are specialized for specific mixes of service. So we have pizza boxes that can do only PON, right? If you just want to optimize around some residential stuff and do some PON, that's great. So then you don't buy a chassis. We have some that do carrier Ethernet and circuit emulation, right? So they have a mix. So, and that's a common combination that we have. So we built them around the common combinations that we see. And we even have pizza boxes that do nothing but Ethernet, but also do provide WDM optics as well, so that you can backhaul directly from those pizza boxes as well. And also in these chassis, we offer many different sizes of fabric. So even, and these chassis range from 2 RU on the left up to 7 RU, 7 slots up to 18 slots. And the fabrics range from 64 kilobits to terabit, and many of them in the same chassis. Like this small chassis has 64 kilobits, 64 gigabits. I'm sorry, they range from 64 gigabits to a terabit. And so the small chassis ranges from 64 gigabits. It has a 200 gig fabric. It has a 300 gig fabric that's coming up. So you can optimize. Remember, that cost of that fabric is pretty substantial. So you can optimize around what you want to deploy. All right. So that's mostly what I want to say about that. I already mentioned that we do both MPLS-TP and Q&Q. Again, webinar tomorrow if you want to talk about that more. And we do have open interfaces to these devices. SNMP, we're in the process of adding NetConf Yang. We have 814 interfaces northbound from our manager. We do offer ONTs as well. We do have some CPE, mainly in the CPE area for carrier Ethernet services. We focus on multi-tenant, so we have some bigger boxes for that kind of stuff. We have ONTs, which are for home and business use, ranging from a port of POTS and a port of Ethernet to maybe 4 or 5 ports of POTS and a couple ports of or 4 or 5 ports of Ethernet and a couple ports of POTS. We have some hardened options as well. We have PON on a stick, which you can stick into any switch or router and turn that switch or router into an Ethernet ONT for the PON system. So if you have if you're delivering business Ethernet services, you already got a switch or router you like to use, plug this little baby in, continue to use that sucker, and start delivering services over PON, which is much more cost effective than doing it over active Ethernet directly. All right. All of these ONTs, by the way, are fully PON standardized via the PON standards. So we support TR69 for remote management. We support the OMCI, so we can interop basically with other people's OLTs as well. All right. So that's it on the product. I just want to leave you with a few takeaways, then we'll get to questions. So COVID, strong demand, right? And especially in the rural areas, especially on the upstream bandwidth, new technologies are needed, like XGS-PON, to increase the amount of capacity to each home. Delivering to rural broadband has its own distinct challenges, distances between people, environmental, we talked about them all. And there are fortunately solutions for all of those out there today. And Tejas, we have one of the most converged broadband solutions in the industry. So hopefully you'll take a look and we can help you deploy these services cost effectively. All right. And before we get the questions, really quickly, I just wanted to say we have a virtual booth session. Alan has sent out a link to that. So right after this meeting, if you can jump onto that, and Alan will jump on, and we can show you equipment, answer specific questions if you want to drill down on anything specifically. So hopefully you'll join us there. And with that, let's take a couple of questions. Alan?
Thanks, Rob. So our first question is service OEM and GPON protection becoming more important? What type of PON protections are more in demand?
Okay, that's a very good question. So, that's two separate questions. So yes. Service O&M, and I'm glad you asked that actually, because I actually have a webinar tomorrow that's focused on premium broadband services, so premium Ethernet services, and it includes broadband services. So yes, service O&M is becoming more important, especially as people are moving their office to their home office. And so essentially what we can do is, if you're offering business Ethernet services over PON, of course PON built into it allows you to designate how much bandwidth that you're sending to each ONT, and each individual user will have their own ONT. So you can control the amount of capacity that they have per their session, but the O&M and the SLA guarantee is not that sophisticated. Now, typically for managing those services, through the OMCI, which is a standard interface that goes down to the ONTs, there are all sorts of standard alarms that get sent up. So we constantly know what the status is of that connection, and we can see it. And many of us also will provide a MEP endpoint. So if you're running Ethernet services in those devices, you can basically run standard Ethernet O&M down to those devices. So not only better O&M, but you also need better SLAs as well. And I'll talk about that a little bit tomorrow. And then on PON, the types of protection, there's actually Type B and Type C are kind of the most common. Type B, I talked about a little earlier. That's where you protect the connection between the splitter and the OLT. And Type C is where you actually protect the connection from the splitter to the end user. So Type B is from the splitter back to here. And like I said, you can provide equipment protection and diverse routing of the fiber. And there's also something called Type C that will allow you to protect from the splitter down to the end user. We don't see as much of a demand for that because you're only protecting an individual user when you protect on that side. On this side, you protect lots and lots of users. All right?
Thanks, Rob. Your second question is, for single fiber DWDM, 10 gig and 100 gig, is it point-to-point only, or does it scale to other network topologies?
It will scale to pretty much any network topology that DWDM will scale to, is the basic answer. Anywhere you can run, in any topology you can run dual fiber in, you can basically run single fiber. Now, there are some additional costs at add drop sites and things like that that come along with single fiber. There's some additional, we use interleavers essentially to combine the signal into a single fiber instead of dual fibers and things like that. So there's some additional costs and things like that that come into play at some of the drop sites. So sometimes, depending on the amount of traffic and stuff that you're dropping and the amount of channels that you're going to add, it may not make sense. Depending on how much you can save. But most of the time you're paying so much, especially if you're leasing that fiber, most of the time you're paying so much for that fiber that no matter what you do with single fiber, it ends up paying off at least within a couple of years. And most configurations will pay off within the first year, basically, just in the money you're saving for that fiber. And if you want to talk to us in more detail, we have an actual customer example and business case for that we could show you in a one-on-one session or in the virtual booth. All right.
Thanks, Rob. Another question is, can you elaborate more on the differences between using MPLS-TP versus Q&Q for service delivery and backhaul?
Yes. So a good lead in again to tomorrow's webinar. So I talk a little bit more about those two different technologies tomorrow. So please join me there. But I'll give you a quick overview as to why people like one or the other. Now, the quick answer is, in terms of the quality of service that you can offer, both of them you can offer the same QoS. There are a lot of things that people like about MPLS-TP. So people look at MPLS, a lot of people, especially in the Americas, are using Q&Q today, but they look to MPLS-TP as a next generation technology. And there are a number of reasons for that. Number one is they're using MPLS in their core network, and MPLS-TP looks and feels and smells like MPLS. In fact, it is MPLS, except it doesn't have IP capability. So you don't have layer 3 VPN. You don't have penultimate hop pop and other things that require layer 3 visibility, but you do have LSPs, you have tunnels, you have pseudo wires. All the stuff is the same. In fact, all that stuff is interoperable as well with MPLS. So people like it for that reason, especially since your backhaul is probably touching your core network at some point. And also it's considered more scalable. So basically, with VLAN technologies like Q&Q, you're limited in terms of the number of services you can deploy by the number of VLANs, which is 4096, right? So if you need lots and lots of VLANs, you eventually run out. And with MPLS-TP, you don't have that issue. All right, so in terms of the quality of service and the amount of bandwidth you can provide, doesn't matter which one you're using. But for all those reasons I just talked about, those are the reasons why people look to MPLS-TP as kind of the future technology.
Thank you, Rob. Well, that's all the questions for today. Again, please join us tomorrow for Rob's session. The virtual booth link that I've given you in the chat will open up in a few minutes as soon as I log into it and turn it up. And we'll be able to show you the equipment, walk through the network management system, whatever you would like to have see in more detail, right? It's a hands-on, it's not chartware. So please drop over and join us. Again, Rob, thank you very much for a great session today.
All right, thank you, everybody.
All right, take care. Thank you.